Welcome to the FAQ Shack, where we tackle your biggest questions on the most fascinating topics. And today, we're diving into a real big one. How on earth did we go from computers being the size of a room to something that fits in your pocket?
So let's kick things off with a listener question about a prediction that, let's just say, didn't quite pan out. Back in 1977, Ken Olsen, the president of a pretty big deal computer company at the time, said this. And it's just wild to hear today.
I mean, can you believe that? Especially when you look at the world now with, over 25 billion connected devices? It's just staggering. So that really sets up our first big question perfectly. How did we make that jump? From these massive room-sized machines to a world where a computer is literally in everything.
All right, so let's get into it. And to do that, we've got to start at the very foundation, with the physical stuff itself. Okay, so the physical evolution was astonishingly fast. We started in the 1800s with Charles Babbage designing these amazing mechanical computers, all gears and levers. Then, bam, by the 1940s, we've got the first generation of electronic computers, but they're using thousands of these huge, unreliable vacuum tubes. Just a decade later, the transistor changes everything, making computers way smaller, faster, and more dependable. And then the real kicker, the 60s and 70s give us the integrated circuit, the chip. Suddenly, you can cram tons of transistors onto one tiny piece of silicon. That right there was the beginning of the modern era.
So what's really cool is that you can think about this whole hardware story as the first level of computing. We'll call it the mechanical level. This is the tangible physical stuff, right? The motherboards, the wires, the silicon chips. It's the world of engineers, a physical system that's all about exchanging energy. It's basically the skeleton, the raw bones that everything else is going to be built on top of.
But, a skeleton's not much use without a brain to tell it what to do. And that brings us to our next big question. When did these hunks of metal actually start to think? The huge leap forward here was this idea of a stored program. The idea that the instructions for the computer could be stored right alongside the data it was working on. Now, this is where it gets a little dramatic. The idea came from a team at the University of Pennsylvania, but then the legendary John von Neumann published this hugely influential report on it, with only his name on the cover. This caused a really bitter controversy. But here's the silver lining. Because of all that drama, the fundamental architecture for pretty much every computer since ended up in the public domain. No patents, free for everyone to build on. And that one idea was a total game changer. It split computing into two separate, but totally connected, worlds. You've got the physical machine, the hardware, and then you have the instructions telling it what to do, the software. This is why your computer can be physically perfect, but still crash because of a bug in the code. And what do? You reboot it. You fix the problem without ever touching the actual machine.
So this is the crucial part. Computing gets this whole new invisible layer. Let's call it the information level. This isn't about energy and wires anymore. It's about, information. It's the abstract world of programs, data, and algorithms. This is where computer science lives. It really is the ghost in the machine.
Okay, so we've got the body, the hardware, and we've got the brain, the software. But that combo still wasn't enough to get a computer into your house. So what was the missing piece? How did these incredibly powerful machines actually become personal?
All right, so machines like the Apple II and the IBM PC were a huge step. They took computers out of the university labs and put them onto office desks. The IBM PC especially kind of standardized everything, which was a big deal. But there was a problem. To use these things, you had to stare at a black screen with a blinking cursor and type in these cryptic commands. Not exactly user-friendly, right? The real revolution was the graphical user interface, the GUI. Now, the ideas were pioneered at this legendary place called Xerox PARC, but it was Apple with the Macintosh in 1984 that really brought it to the world. All of a sudden, instead of typing commands, you were clicking on little pictures, on icons. You had windows, menus, and this weird new thing called a mouse. It was intuitive, and for the first time, anyone could use a computer.
And this is our third level, the personal level. The whole focus shifted. It wasn't just about, does the hardware work? Does the software run? It became, can a normal person actually use this thing? It became a psychological system, all about human-computer interaction. It was about making technology serve us, not the other way around.
So millions of people now have these personal computers on their desks, but they're all basically digital islands. The next step was to connect all those islands together and build a new world.
And just like before, it happened in stages. It started with a US government project called ARPANET. Then, Vint Cerf and Bob Kahn came up with TCP/IP. Think of it as a universal translator for computers that let all these different networks talk to each other. And then, the final piece. Tim Berners-Lee invented the World Wide Web. You know, hyperlinks and web pages. He gave the internet a user-friendly face.
And this whole global network is powered by something we now just call the cloud. Instead of you needing to own a massive, expensive server room, you can just rent a slice of someone else's. The cloud is basically a network of enormous data centers that we can all tap into. It's the engine that runs everything from Netflix to Instagram.
And with the internet, we get our fourth layer, the community level. All of a sudden, computing wasn't just a personal tool anymore. It became a social one. It became a system for exchanging ideas, memes, culture, you name it. It created online communities and social networks. It basically rewired how we interact.
Which brings us right up to today, and our final, future-looking question. What happens when this global community isn't just made up of people? What happens when we start sharing it with AI?
We are now stepping into the era of what people are calling agentic AI. A normal program is a tool. You tell it, do this, and it does it. An AI agent is different. You give it a complex goal, and it figures out the steps to get there all by itself. We're already seeing this happen. Salesforce has agents that can handle customer support, and Darktrace has agents that hunt for cyber threats. There are even tools like Cursor that can act as an AI software engineer. The really wild part is that you can interact with these agents almost like a human coworker. You can give them instructions in plain English. They'll come up with their own plan of action. You can even give them feedback and coach them to get better over time. They're not just tools anymore. They're becoming teammates.
But there's a catch. This incredible new layer of intelligence takes an absolutely colossal amount of computing power, so much so that it's pushing our current hardware to the breaking point. And so, in a funny way, the next big evolution takes us full circle, right back down to where we started. The hardware, the mechanical level.
And this is where some really futuristic-sounding stuff comes in, like neuromorphic computing. The idea is basically, what if we design new chips that are structured more like a human brain? The whole goal is to build hardware that can run these super powerful AI systems way, way more efficiently, using a fraction of the power. So, let's wrap it all up. The story of computing has really been a story of adding new layers. We went from the physical machine to the invisible software, to the personal interface, to the global community. And now, we're adding this new powerful layer of intelligence. Which leaves us with one final big question to think about. As computers evolve from tools we command into teammates we collaborate with, how will we have to evolve too?